All right, guys. So here in section 11.3, we're going to be talking all about what are called central angles as well as arcs. So let's go ahead and jump straight into things. Let's talk about the definition for both of those two terms. Starting with central angle. So a central angle is an angle whose vertex is on the center of the circle and whose sides then are radii. In other words, on this circle ABC that we've got here, your central angle would be this angle that I've highlighted right here. That would be angle ABC. So that would be the central angle. The arc then is the section of the circle which is cut by that angle. So while the angle is that angle that's formed between the two radii, the arc is the actual piece of the circle, which I'm highlighting in red here for us, that is cut off by that angle. When we write arcs, the notation for that is you say the two letters that form the arc, so A and C are the 2 points, and then you just draw a small arc over those two letters. Now that would also work going in the other direction, so if you'd rather call that arc CA rather than AC, you'd be talking about the same arc. Either one of those would be okay. Now there's going to be several different types of arcs. We're going to look at basically three. The first of which is what's called a minor arc. So a minor arc is the arc in the interior of the central angle. So again, going back to that same circle, if you have B as the center, A and C on the sides, then your minor arc would once again be that arc AC that we were talking about before. Now that's different from what's called the major arc. So the major arc is on the exterior of that central angle. So instead of going the short distance to AC, for a major arc, we go the long way around. Now to make sure that we say it differently, because it wouldn't make much sense to just call it AC as well, we try to pick some other point which is in that distance and put that in the middle. So in other words, the major arc would be AXC. Or again, you could go the other way and say CXA, but that would be how you would describe a major arc as opposed to a minor arc. Finally, there's what's called semicircles. This is an arc that is exactly half of the circle. These are always formed by the diameter. So when you look at the diameter of your circle, which again is that chord going through the center, that would be a semicircle. Again, this should be pretty straightforward. You could basically have two different semicircles on this particular circle. The first one that I've highlighted here in green for us would be the semicircle ACB, which again, if we're going to talk about it using arcs, we'd say it this way. Or you could also look at the one that's formed by going from A through D to B. And again, that would also be a semicircle. And again, you would write that kind of like this. And again, as I write these, you could also write them backwards as well. So if you wanted to say BCA instead of ACB, that would work. Same with BDA. So now let's talk about the measures of our arc. So when we measure an arc, when you measure a minor arc, it's going to be equal to the measure of your central angle. So in other words, if your angle right here is, let's say, 70 degrees, then the measure of your arc, we're going to also say is 70 degrees. In other words, angle ABC, and the measure of that angle is equal to the measure of our arc ABC. So they are equal to the same thing. So again, if one of them is 70, then the other one would be 70 degrees as well. But when we talk about a major arc, that's going to be slightly different. So it's going to be equal to 360 degrees minus the measure of that minor arc. So if this is 70 degrees, and the entire circle has to be 360 degrees, then if you take 360 degrees minus that 70 degree arc that we've got, that tells us that what's left over is going to be the major arc, which 360 minus 70 is 290 degrees. That would be the measure of this arc right here from A to X to C. So again, when you measure a major arc, you go the long way around, and that's going to be found by taking 360 minus the measure of your minor arc. Now, semicircles are probably the easiest arcs to measure. They have to be exactly 180 degrees, and so those are pretty easy when it comes to measuring. Now, one important postulate that we have is what's called the arc addition postulate, which basically says that two adjacent arcs can be added together to find the measure of the larger arc, which is made up by those two smaller ones. In other words, if you take this arc AB right here, plus this arc BC right here, then that's going to add together to form the entire arc from A to C. So if you wanted to write that with notation, you would say that the measure of arc AB plus the measure of arc BC is equal to the entire arc, the measure of AC. All right, so let's do some practice problems using arcs so we can kind of see how all of this works. So on this first example, we've got our circle right here, and it looks like we're missing just one piece of the circle. We're missing our piece from A to F. So before we do anything else, let's just go ahead and find that missing piece, and that way we know what everything measures to be. And to remember that the entire circle has to add up to be 360 degrees. So if we take 360 minus each of the other measures, so minus 120, minus 41, minus 100, and then finally minus 55, that's going to give us the measure of that arc that we're missing, which when you do that ends up being 44 degrees. So that's going to be our measure for our arc AF or FA, depending on how you want to write that. That was the only one that we were missing. So let's go through and let's find the measure for each of these arcs. Let's start with our measure of arc DF. So DF would be the measure of this arc that I've got highlighted in blue, which we already know is 41. There would be our measure for arc DF, or rather DE. So let me go back and fix that. We want to find DF, not DE. So we need to do a little bit more. So DF would be actually this entire distance right here. So that would be 41 plus 120, and 41 plus 120 is 161 degrees. There would actually be our measure for DF. So I need to be a little bit more careful with that. Next, it asks us to find the measure of arc ECA. So that would be starting at E, going through C. So that's important to know which direction you're going, and then ending at A. So everything I've got highlighted in green. So that's going to be 41 plus 100 plus 55, which when we add all those together, that's going to add up to be 196 degrees. And there's our measure for arc ECA. The next one's going to be pretty easy. The measure of arc AF, that was one that we found at the beginning, the one that was missing from the rest of the circle, and that's going to be 44 degrees. For this last one, I'm going to go ahead and erase some of this stuff to make it a little bit easier to see. The one thing I'll leave on there will be that 44 degrees for AF, and let's go ahead and find this last one, which is the measure for CFD. So starting at C, going around to F, and then ending at D, we can go ahead and find that one of two ways. If we wanted to add together these four numbers that I've underlined, that would be one way to do it. But the easier way would be to just take 360 minus the section we don't want. We don't want from C to D. So that would be to take 360 minus 100, and that's 260 degrees. That would be the measure of arc CFD. Okay. For our next example, let's go ahead and look at that now. We've got our circle, which it looks like has been cut into a semicircle, and then we've also got some other measurements that are given to us. If we already know this is 36 degrees, then over here where we have those double tick marks again, that would also have to be 36 degrees. Now remember, for each semicircle, it has to add up to be 180 degrees. So to find the missing pieces, if we take 180 minus 36, which is on the left side, that's going to be 144. So that's going to be our distance from A to E. In fact, that's also the very first one that was asked for. So 144 degrees for that first one. We can also do the same thing on this right side. So if we take 180 minus 87 minus 36, that subtracts to be 57 degrees. That would have to be this distance from A to B. In fact, That was the next one that we were looking for. Next, we'll go ahead and find the measure of arc C to D to B. So starting at C, going through D, all the way around our circle back to B. And again, if you want to add up all those numbers, you can, but probably easiest to take 360 minus that 36 degrees that we do not want, which is 324 degrees. There would be the measure of CDB. All right. And then for this last one, what we want to find is we want to find the measure of arc BD. So that would be from B right here to D right here. That would be 87 plus 36, which adds to be 123 degrees. And there would be that measure of our last arc that we needed. Okay, let's take a look at two last examples here, and then that should be it for this section of the notes. So we're given this circle B with our diameters, which are HC, EG, and DA. In other words, we've got three different diameters there that we've written in. So let's do this. Let's go ahead and find the measure of those missing angles that we were not given. And the two easiest to start off with would have to be the vertical angles. So if you had 61 degrees here, that's also 61 here, and then 38 here would also have to be 38 degrees here. So then what I'm going to do to find the missing angles that we don't have, remember, all of these are diameters. I'm going to focus on this diameter right here, which is from A to D. And remember that when you have a diameter, it splits it into a semicircle where each of those has to add up to be 180. And so if the entire distance is 180, if we take 180 minus the 61 minus the 38, which are both angles that we know, we should get our missing angle, which turns out to be 81 degrees. And the nice part is once we found one of those, just go across the circle to the other one, which also has to be 81 degrees. And now we've got all of our angles that we should need to work with. So let's go through now and let's answer some of these questions. So it first asks us, what is the measure of DBH? So DBH would be this angle right here, which I'll highlight in red for us. That's going to be the 38 degrees. So that one, pretty easy. Next, we want to find the measure of DCE. So from D, wrapping through C all the way around to E, which again, the easiest way to do that is to take 360 minus that section that we do not want. So minus 61, which is 299 degrees. And there would be your measure for angle or for arc DCE. Next, we're going to find the measure of HG, which HG, pretty easy. That's this arc right here, which is the 81 degrees right here. That's all we have to do for that arc. Okay, so before we move on, let me go ahead and erase some of these colorful kind of in there and get this cleared out for these last three. So next we want to find the measure of arc HCF. So HCF would be starting at H, going through C, and then connecting at F right here. Now, in order to do that, there is actually this other piece of information right here that we're going to use. So we're going to take that 22 degrees plus our 38, 81, 61, and 38. So quite a few numbers to add together. Feel free to use a calculator for this part to add all those numbers together. When you're done adding all of those up, you should end up with 240 degrees. All right. I'm going to go ahead and circle some of that, or erase some of that so we can see a little bit more clearly. Now we're ready to find the measure for angle HBA. So HBA would be this angle right here. So H to B to A, that would be 81 plus 61, which adds to be 142 degrees. Again, that's 81 plus 61. All right. And then for our last one here, we're asked to find the measure for angle DBA. So DBA would be this right here, which while you can add up those three numbers together, that's also a diameter. That means that it's a semicircle. So right away, we can know that that angle is 180 degrees. Okay, one last example to look at here. We've got what are called concentric circles. So concentric circles are simply two circles which share the same center for those circles. And we're given some information about these concentric circles. We're told that the measure of arc GF is 76 degrees. In other words, this arc right here is 76. That also means that this arc right here is also 76 degrees. Next, we're told that the measure of HIE is 147 degrees. So that would be 147 right here and 147 right here. Finally, we're told that CA and FH are diameters, so we know that those are going to have to add up to be 180 degrees. So let's find those separately. First, let's look at using our diameter of C to A. So that's going to separate into two separate sides, both of which have to add up to be 180 degrees. On the right side, if we take 180 minus 147, that's going to be 33. That's going to be the measure for our two missing arcs on that side. Then on the left side, we'll do the same thing. We'll take 180 minus 76 this time, which is 104 degrees. That's going to be the measure for these two missing arcs right here. All right, so let's go ahead and answer some questions now. Our measure of arc CB, so from C right here around to B right here, pretty easy. We've already found that. That's 104 degrees. Next is going to be the measure for HE. So for HE, that should also be pretty easy. That's going to be this arc right here, which we already know is 147 degrees. Next, it wants us to find the measure for arc BDC. So starting at B, we're going to wrap around to D, and then we will continue to wrap that around all the way to C. And so one way would be to add together these three numbers that I've underlined in green. The other would be to just take 360 minus that section that we don't want, which is 360 minus 104, and that's going to subtract to be 256 degrees. There's going to be our measure for arc BDC. All right, going to erase some of these colors on here real quick so we can take a look at this last question. And that way we don't have to be confused. Going to have to rewrite a couple of those, but I think that we're good. All right. So lastly, we're asked to find the measure for angle CIB. So that would be from C, which is right here, to I, which is right here, to B, which is right here. That's going to be this angle right here, which once again, we already know to be 104 degrees. And it looks like that's going to be it. So hopefully that makes sense. Again, arcs and measures of arcs are pretty easy as long as you remember those rules for angles that we talked about way back when. Until next time, guys, have a great rest of your day.